All right, today we're going to venture way past the big familiar planets. We're going to explore the smaller, kind of weirder, and honestly, way more dramatic residents of our solar system. So let's get this cosmic journey started.
So when you think of the asteroid belt, you probably picture something like this, don't you? You know, this dense, chaotic mess of tumbling rocks where you need the skills of a starfighter pilot just to get through. It's such an iconic image from the movies. But is it real?
Yeah, no, not even a little bit. That Hollywood version, it's pure fiction, cooked up for maximum on-screen drama. The real asteroid belt is something completely different, and frankly, it's way more vast and mind-boggling than a traffic jam of rocks.
Just how empty is it? Well, get this. The average distance between any two asteroids is over 600,000 miles. That is more than double the distance from the Earth to the Moon. Space is just so incredibly empty out there that when we send our probes, like New Horizons, right through the belt, the chances of it accidentally hitting anything are practically zero.
Okay, so our first stop on this tour is the asteroid belt itself, this amazing region of space hanging out between Mars and Jupiter that holds all these rocky remnants of, well, what could have been a planet.
So what even is an asteroid? The best way to think of them is as cosmic leftovers. You know, back when our solar system was just getting started, bits of rock and metal were clumping together, building the planets. Well, asteroids are basically the building blocks that never quite got the job done.
And here's something that might surprise you. Even though there are likely over 1 million asteroids out there, if you could somehow scoop them all up and put them together, their total mass would be less than our own moon. They're mostly these lumpy, potato-shaped, cratered bodies, with the real giant of the bunch being Vesta.
And that's the big question, isn't it? I mean, if you've got all these rocky building blocks just floating around in the same general area, why didn't gravity just pull them all together and make a fifth rocky planet? What went wrong?
The answer is one word, and it's a big one: Jupiter. The gravitational pull from that gas giant is just unbelievable. It was constantly tugging and pulling on these little rocky bodies, stirring up their orbits so violently that they could never really settle down and clump together. Jupiter kept them in a state of constant cosmic disruption.
Okay, quick break to clear something up that trips a lot of people up. So when a small piece of this rock is just floating around in space, we call it a meteoroid. Simple enough. When it hits our atmosphere and burns up, creating that beautiful streak of light we call a shooting star, that's a meteor. And if a piece of it actually survives that fiery trip and lands on the ground, that's a meteoroid. Got it? Good.
Now, let's strap in and travel much, much farther out, to the cold, dark edges of the solar system. It's time to meet the icy cousins of the asteroids, the comets.
This is the classic way to describe them, and honestly, it's perfect. The core of a comet, its nucleus, is just this jumbled mix of ice, rock, and dust, all frozen solid. For most of its life, way out there in the deep freeze of space, that's all a comet is, just an inert, dark, dirty snowball. But things get really spectacular when a comet's orbit brings it close to the sun. As it starts to heat up, the ice turns straight into gas, creating this glowing atmosphere around it called a coma. And then, the solar wind and sunlight actually push that material away from the comet, forming two different tails. You get a straight, bluish gas tail and a more curved, whitish dust tail. It's quite a show.
So where do these things come from? Well, I have two main hometowns. The first is the Kuiper Belt, which is kind of a donut-shaped ring of icy bodies out beyond Neptune. Comets from here tend to orbit in the same flat plane as the planets. But way, way beyond that is the Oort cloud, a giant spherical bubble that surrounds our entire solar system. Comets from there can come at us from literally any direction.
And speaking of the Kuiper Belt, that brings us to its most famous resident. Let's explore this distant, icy kingdom through the eyes of one of the greatest robotic explorers humanity has ever built.
I mean, just look at this incredible voyage. The New Horizons probe launched way back in 2006. It swung by Jupiter for a speed boost in 2007, and then spent another 8 years just cruising through the darkness to finally reach Pluto in 2015. And it didn't even stop there. It just kept going, deeper into the Kuiper Belt, for a 2019 meeting with an even more mysterious object.
So this is the big one. Why isn't Pluto a planet anymore? Well, back in 2006, astronomers updated the official definition. A planet has to do 3 things. Pluto does the first 2 just fine. It orbits the sun, and it's big enough that its own gravity has pulled it into a round shape. But it's the third rule it fails. It has not cleared its neighborhood, which is a fancy way of saying it shares its orbital path with a ton of other objects out in the Kuiper Belt.
Before New Horizons, Pluto was just a blurry dot in our best telescopes. But what we found when we got there was absolutely staggering. We saw a complex, active world with towering mountains made of rock-hard water ice. It has vast plains of flowing nitrogen ice that make up its famous heart. It even has a thin atmosphere. This was no dead, boring ice ball. Not at all.
After Pluto, New Horizons flew on to this thing, Arrokoth. It's one of the most ancient, primitive objects we've ever visited up close. It's what's called a contact binary, basically two separate little worlds that gently bumped into each other and just stuck. This pristine relic, which kind of looks like two pancakes fused together, gives us a direct look at how planets might have started forming over 4 billion years ago. It's a time capsule.
Okay, let's bring this entire journey back home, because these small objects, these asteroids and comets, they aren't just distant curiosities. They have played a really profound and sometimes incredibly violent role in the history of our own world.
It's probably the greatest mystery in the history of life on Earth. For millions and millions of years, dinosaurs ruled this planet, and then, about 65 million years ago, poof, they were gone. Could the culprit have come from outer space?
Well, the evidence is pretty darn compelling. Scientists discovered a thin layer of an element called iridium all over the world in rocks that are exactly 65 million years old. Iridium is super rare on Earth's surface, but it's very common in asteroids. And here's the ticker: dinosaur fossils are always found below this layer, never above it. The Smoking Gun? A huge impact crater, the exact same age, found off the coast of Mexico.
The object responsible for all that chaos is estimated to have been about 10 kilometers. That's 6 miles wide. Imagine an object the size of a mountain, slamming into the Earth with unimaginable force. It literally changed the course of life on this planet forever.
And this brings us right back to Jupiter. It plays this fascinating double role in our story. On the one hand, it's our guardian, our gravitational shield. Its immense gravity has kicked countless dangerous comets completely out of the solar system. But, on the other hand, its gravity can also act like a cosmic sniper, giving a comet or asteroid a little nudge onto a brand new path, a path that could lead it right toward us.
So we're left with this really interesting question. The very same gravitational force that stopped a planet from forming in the asteroid belt, and the same force that protects us from so many impacts, is also the same force that can send absolute destruction our way. It's just a powerful reminder of what a dynamic and sometimes dangerous solar system we call home.